let's take a closer look at the index laws. So we've got 4 index laws here. There are more, but we're just going to focus on these at the moment. So those are the laws, and I'm going to give you a quick example. So we refer to this as the base and this as the power or the exponents. And for these laws to work, we need the bases to be the same. So for example, if we multiply m squared multiplied by a squared, we can't add the powers. That would just become m squared, a squared. Okay, so let's look at some numerical examples first, and then we'll take a closer look at the each rule. Okay, so 2 squared multiplied by 2 cubed. We add the powers. 2 plus 3 is the same as 2 to the 5. Okay, the second power, let's have 2 to the 10 divided by 2 to the 8. The base is the same, so we subtract the powers to get 2 squared. Here, we've got 2 to the 8 squared, and our index law here says that we can multiply the powers to get 2 to the 16. And here, we've got anything to the power of 0 is 1. So 2 to the 0 is 1, 3 to the 0 is 1, and so on. Okay, so let's take a closer look at each index law. Okay, so why does a to the m multiplied by a to the n equal a to the m plus n? So let's use a numerical example. Let's do 2 squared multiplied by 2 cubed times 2 to the 4. Okay, so effectively this is 2 times 2. That is the 2 squared. The 2 cubed is 2 times 2 times 2. And the 2 to the power of 4 is 2 times 2 times 2 times 2. Okay, that is the 2 squared, that is the 2 cubed, and that is 2 to the power of 4. Now effectively, you're adding each 2 each time you multiply. So this is 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, 2 to the 8, 2 to the 9, which is the same as just adding the powers here. 2 plus 3 plus 4 is the same as 2 to the 9. Okay, so let's have a look at 3 numerical examples, then we'll do an algebraic one. So let's do 2 to the 5 times 2 to the 6. Let's do 2 to the 4 multiplied by 2 to the 9. Let's do 2 cubed multiplied by 3 squared. Okay, so we can add the powers. 5 plus 6 to give 2 to the 11. Here we can do 2 to the 4 plus 9 to give 2 to the 13. Now here, you cannot add the powers because the bases are the same. So the best thing, the only thing you can do with this is just to evaluate it. So 2 cubed is 8, 3 squared is 9, So we get 8, 9, 72. Okay, so let's have a go at doing some algebraic ones. So let's do 2 examples first. Let's do m to the 8 times m to the 9. We add the powers because the bases are the same. 8 plus 9 is m to the 17. Okay, so let's look at a different example. Let's do 2m squared multiplied by 3m cubed. So let's do the coefficients first. Coefficients are the numbers or letters in front of something. So, for example, the coefficient of m squared there is 2, and the coefficient of m cubed is 3. So 2 times 3 is 6. And the bases are the same, so we add the powers to give 2m to the 5. Let's do one more example, then we'll do some 3 questions. Let's do 8y to the 8 times 5y to the 5. Okay, let's multiply the coefficients first. 5 8s are 40. Then we've got y, and we can add the powers to get 13. Okay, let's do 3 questions. I would like you to pause the video and see if you can simplify these expressions, leaving your answer in insert forms. Let's do 2y cubed multiplied by 8y to the 4. Let's do 5m squared multiplied by 5m squared. Let's do 6y squared multiplied by 7y squared. Okay, so pause the video and see if you can simplify these, leaving your answer in index form. Okay, so hopefully you've done that now. 2 times 8 is 16. We add the powers. 4, 5, 6, 7. 5 times 5 is 25. We add the powers to get 4. 6 7s 42. We add the powers to get y to the 4. Okay, so let's look at the second power. The second index law. Second index law was the division one. And it said that if we've got a to the m, a to the m divided by a to the n, that is the same as writing a to the m minus n. Now, I prefer writing this index law like this. So if we've got a division sign there, those little dots stand for numbers. Those little dots stand for numbers. And the posh word for the line is it's called the vernaculum. Let's do an example then. Let's do an example of why this works. Let's have a look at 2 cubed divided by 2 squared. Okay, so let's write this out then. Like this. That is the same as doing 2 times 2 times 2 over 2 times 2. Now, we can cancel the 2. Don't forget, multiplying by 2, then dividing by 2 is the same as multiplying by 1. Okay, so here we get 2 to the 1, which is the same as doing 2 to the 3 minus 2, which is just 2 to the 1. Okay, if you don't understand that, you can still apply this index law. Let's do an example. Let's do 2 to the 100 divided by 2 to the 80. Well, the bases are the same, so we do 200 minus 80, which is 2 to the 20. Let's look at one more. Let's do 9 to the 11 divided by 9 to the 8. Well, the bases are the same, so we subtract the powers to give 9 cubed. Okay, let's do 3 really quick questions and then we look at some algebraic questions. Let's do 1, 2 to the 8 divided by 2 to the 7. Let's do 2 to the 4 divided by 2. Let's do 2 to the 14 divided by 2. Okay, hopefully you can recognize that that is the same as 2 to the 8 minus 7, which is just 2 to the 1. This is 2 to the 4 minus 1. If there's nothing there, we just take a 1, give 2 to the 3. This is 2 to the 14 minus 1, which is 2 to the 13. Okay, so let's look at some algebraic ones then. Let's do 3 examples, and I would like you to pause the video to answer some of these questions. So let's look at 12m cubed divided by 4m squared. So pause the video and see if you can do this one. Okay, so I like to write this 12m cubed over 4m squared. Okay, 12 divided by 4 is 3, and we subtract the powers just to get m. Let's look at one more. Let's do 15. 15m to the 7 divided by 3m squared. Okay, so (15) divided by 3 is 5. We subtract the powers to get m to the 5. Okay, let's do 3 really quick questions. Let's do 5m squared divided by 5m. Let's do 6m cubed divided by 2m. Let's do 72m to the 8 divided by 8m. Okay, so I like to rewrite this. 5 divided by 5 is 1, and we subtract the powers just to get m. And we can show that by doing this. 2 minus 1 is 1. Okay, so we've got 6m cubed over 2m. 6 divided by 2 is 3. Subtract the powers to get m squared. Okay, so we've got 72m to the 8 all over 8m. Well, 8 nines is 72, so that's going to give 9m. Subtract the powers to get 7. Okay, so let's have a look at the third index law. The third index law states that if we have a to the m, n, that is the same as doing a to the m, n. Let's look at that numerically then. Let's have a look at 2 cubed squared. Now, this is 2 cubed multiplied by 2 cubed. It's effectively what squared means. It means something multiplied by itself. So then we can add the powers there and use our first rule, which is 2 to the 6. Which, if we do 2 cubed twice, that is the same as, and we add them, That's the same as multiplying. Let me give you another example. Let's do 5 squared 3 times. So that is 5 squared times 5 squared times 5 squared, which is 5 to the 6. So 3 is just really an application of rule 1. So let's have a look at some numerical examples. Okay, so let's do 2m squared. Okay, I said numerical. Let's do 2 squared to the 7. So we do 2 times 7 is 14. See if we can do this one. 3 to the 4 to the 4. And that is just 3 to the 16. Okay, let's do 3 numerical examples, and then we look at some algebraic ones. Let's do 7 squared times 7. 7 squared to the 7. Let's do 8 to the 9 squared. And let's do 8 to the 11 to the 2. Okay, so we apply our index laws. So we got 7, multiply them, 14. 8, 2 9s at 18. Then we got 8, multiply them, 22. Okay, so let's have a look at some algebraic examples. Let's do m cubed to the 7. So that's just the same as doing m to the 21. 3 7s and 21. Let's have a look at doing 2m to the 3 cubed. Now, that is the same as doing 2 cubed m to the 9. 2 cubed is 8, because 2 times 2 times 2 is 8. M to the 9. Let's look at one more example. Let's do 3m squared cubed. So that is the same as 3 cubed, m to the 6. 3 cubed, 3 times 3 is 9, 3 9s are 27, m to the 6. Okay, so let's do 3 examples. Pause the video and have a go. Let's do 2x squared to the 4. Let's do 3m to the 7 to the 4. And let's do 2m squared y cubed all to the 3. Okay, I'd be interested to see how we go on 3, as we haven't done two variables next door to each other, but the principle is the same. Okay, so pause the video and have a go at doing these. Okay, so hopefully you've had a go with them. So that is 2 to the 4 to the 8. 2 2s are 4. 2 4s are 8. 2 8s are 16. So we get 16x to the 8. Okay, so here we have 3 to the 4. 4 7s are 28. We work out 3 to the 4 just by doing 3 times 3 times 3 times 3. Well, that gives 9. That gives 9. 9 times 9 is 81. M to the 28. Okay, so we've got 2 to the 3. M to the 6, y to the 9, and 2 cubed is 8, m6, y to the 9. Okay, so let's finally go on to the last one, and let's explore why m to the 0 is 1. Okay, well, let's use a numerical example. Let's use m to the 7 divided by m to the 7. Now, we know that this is going to be 1. So if we divide the same quantity by itself, we're going to get 1. 3 divided by 3 is 1. 7 divided by 7 is 1. M to the 7 divided by m to the 7 is 1. Let's use our index laws for division. 7 minus 7. That is m to the 0, and we know it's equal to 1. Okay, so this is a really popular question because lots of students get it wrong. So let's simplify 3 questions. 7 to the 0 times 7. Let's do 7 to the 0 squared times 3. And let's do 7 to the 0 times 7 to the 0 times 7 to the 1. Okay, so anything to the power of 0 is 1, times 7 is 7. Here, anything to the power of 0 is 1, so we got 1 squared times 3. 1 times 1 is 1, so we're just left with 3. 1 multiplied by 7 gives 7. Okay, so let's look at some examples. Let's do 4 examples here using m to the 0. So let's do m to the 0 squared multiplied by m squared, all divided by m to the 0. Let's have a 2. Let's do y to the 0 multiplied by 7, all divided by 7 times y to the 0. Let's do 2m squared, all to the 0, divided by 2m to the 0, all squared. Okay, so anything to the power of 0 is 1, so we get 1 squared multiplied by m squared, all divided by 2 times 1. Okay, so 1 times 1 is 1, so we got m squared, 2 times 1 is 2, so we got m squared over 2. Okay, so anything to the power of 0 is 1, so we got 1 times 7, all over 7 times 1. Well, I hope you can see that that is 7 over 7, which is just simply 1. Okay, anything to the power of 0 is 1, so 2m squared to the power of 0 is 1. Here, we've got 2. This is going to give 1, but it's all squared. So we've got 1 over 2 2's are 4, so we're left with a quarter. Okay, so let's finish with 3 quite difficult questions, which combines all of the rules. So let's do the first one. Let's do 2m squared multiplied by 3m cubed divided by 2m to the 0. let's do 2m cubed multiplied by 3m squared to the 4 divided by 2m squared all squared. And we're going to run out of space. So pause the video and see if you can apply your index laws, and we'll do the solution after. Okay, so hopefully you've done the solutions for these. So I recommend dealing with the numerator first, then the denominator, then doing the entire expression. So let's deal with the numerator first. 2 times 3 is 6, and we can add the powers. 3 plus 2 is 5. Let's deal with the numerator. We've got 2 times anything to the power of 0 is just 1. So that leaves us 6m to the 5 all over 2. 6 divided by 2 is 3m to the 5. Okay, so let's apply the same principle. Numerator first, then denominator, then consider the entire expression. Well, looking at the numerator then, we've got 2 times 2 times 2 is 8, m to the 3, multiplied by 3 times 3 times 3 times 3, that's 3 to the power of 4, is 81. 2 times 4 is 8. All over, we've got 2 squared is 4, m to the 4. So we need to find 81 multiplied by 8. 8 times 8 is 8. 8 eighths is 64, so 648. So we got 648. We add the powers. 8 plus 3 is 11. All divided by 4m to the 4. Okay, so we need to divide 648 by 4. So we can half it twice. That's an easy way of dividing by 4. So half of 648 is, let's do this in stages then. Half of 648 is 324 over 2. And let's simplify the m's. So we got 11 minus 4 gives 6. And let's half it again. Half of 324, well, a half of 300 is 150, 162 m to the 6. Okay, so I hope that makes sense. Let's look at another difficult one, and then we will finish. Okay, so let's look at 5m squared all to the 0 times 5m cubed squared times 5m squared cubed all over 5m squared squared. Okay, so let's deal with the numerator first. So anything to the power of 0 is just going to be 1. Okay, 5 squared is 25, and we've got m to the 6. We've got 5 cubed, which is 125, and then we've got m to the 6 all over 5 squared is 25, m to the 4. Okay, so we could multiply 25 by 125, but we've got a division here. So we can just cancel out the 25s. multiplying numerator and denominator by 25 is the same as multiplying by 1, because 25 divided by 25 is 1. So what are we left with? We are left with m to the 6, because 1 times m to the 6 is m to the 6, multiplied by 125 m to the 6, all divided by m to the 4. So that is 125 m to the 12 divided by m to the 4. And we use our rules for division to get m to the 8. Okay, I hope this helps.